Technician A says, this is fuel and emission test 12. This is the one that I passed out before Thanksgiving. Technician A says, high hydrocarbon emission levels are often caused by a fault in the ignition system. Technician B says, high CO2 emissions are usually caused by a richer than normal air fuel mixture. Wait a minute. High CO2 emissions? When you're looking at your exhaust gas analyzer, and there's a couple of you guys over there doing that right now, in addition to, abusing some motorcycles over there, we got to...
Let's not publicize that, please.
Sorry. Okay, high CO2 emissions are, if you look at the desirable window in your exhaust emissions, CO2 should be high and everything else should be low. Got it? That's basically what your exhaust gas analyzer, the graph on your exhaust gas analyzer shows that. And like I've said before, we breathe out CO2, the cars breathe out CO2, cows breathe out CO2, not a problem. Okay, so let's say that again. Technician A says high hydrocarbon emission levels are often caused by a fault in the ignition system. Is he right?
Yes.
Okay, now how are faults in the ignition system will cause high hydrocarbon levels?
Because if it's putting too much fuel in there.
What's that got to do with ignition?
Details.
No, ignition system is not going to determine how much fuel goes in.
It's just going to start it, that's it.
Exactly. Well, so, somebody explain that to me. Somebody asks you, let's say you're going for a job interview and they're going to pay you really good money, and they ask you, how can faults in the ignition system cause high hydrocarbon problems? Problems with high hydrocarbon emission levels.
It's not burning off that fuel.
Yeah, not burning off the fuel?
Well, it's not.
Burning off, what do you mean? Oh.
With fire.
If there's no combustion in that particular cylinder.
Yeah, misfire and spark plug, fuel's not burning, fuel is hydrocarbons, goes out the pipe, you got high hydrocarbon emission. Got me? You might notice over there that there's a difference. Whenever you kill a spark plug and when you kill an injector, it's going to have, you'll have a skip on that cylinder, but it's going to have different effects on the exhaust stream as far as hydrocarbons and that kind of thing. So keep that in mind, and that's something you're supposed to do. One of those worksheets your guys are working out are supposed to do that. That may be hard to do on your motorbike too, but I don't know.
Well, we're doing it on the Honda.
So technician B says high CO2 emissions are usually caused by richer than normal air fuel mixture. If we took out that 2, that guy would be right, but because they put that 2 there, he's wrong. So that's
I thought that CO2 could be caused either by rich or lean, depending on some other factor.
Well, CO2 is what you're wanting.
Well, I mean, I thought it didn't have anything to do with rich or lean.
Well, CO does, because remember what I told you about the way that the fuel works? You got hydrocarbons, which is your fuel, and every hydrocarbon molecule wants to get married to 2 oxygen molecules, and when you got that, you got CO2, right? So if the air-fuel mixture is a little too rich, if you got too much fuel and not enough air, you don't have enough for everybody to get 2 molecules. Some of them only have 1, and then you wind up with CO. Got me? If you've got a rich air-fuel mixture, you're going to have some CO. You can have a lean air-fuel mixture with misfires, not enough fuel in there for it to fire, and you can have an increase in CO because of lean air-fuel mixtures if the conditions are right, if you have a lean misfire.
HC is burning.
Hydrocarbon is actually uniting with oxygen, and that's what's happening when anything burns. It
When you got
oxidizes.
too much of that, you burning what?
If you've got not enough, if it's not balanced, it's got to be balanced. You got to have the right amount. If everything is like it's supposed to be, and these engines we've got here, one's running, you're going to have your CO2 is going to be really high. Everything else is going to be
I'm
low.
talking about HC and CO determine lean.
Yeah, HC is your gas, and O is your air. So you don't have CO until you have some oxidation. And when a fuel burns, you have some molecule that's a CO or a CO2. Got me? All right. But anyway, your CO2 is actually what you're looking for, though. If you've got high CO2 and low hydrocarbons and carbon monoxide, it's optimum. There's also oxygen and there's water vapor in there and whatnot. But hydrocarbons and carbon monoxide, which is CO, are high and CO2 and O2 are low, this can be caused by what?
Rich.
A rich mixture will cause that. That's what we were just saying up here. Which gas is usually considered to be the rich indicator? The higher the level of this gas, the richer the air-fuel mixture. That's going to be your CO. This is what we're trying to burn in here. And I am encouraged by the fact that I'm actually getting the answers from the crowd out here. Which gas is generally considered to be the lean indicator? The higher the level of this gas, the leaner the air-fuel mixture. Oxygen, O2.
O2.
What is O3?
Ozone
And how do you get it?
by,
I want to make some ozone.
spark.
Yeah, spark actually does that. Whenever you've got lightning or anything, you're making ozone when you do that. Matter of fact, some of those gray distributor caps that Ford's had on them early on, whenever all that ozone in there, if there wasn't a vent in the distributor cap, it would actually trap ozone in there, and it would make this gooey, clear stuff that would act just like moisture. Is there somebody out there?
Exactly. Nobody important.
Oh, okay. All right. Well, hopefully he'll know what to do. All right. So sometimes I had to put Garrett with him to keep him on track there. So, all right. Let's see. Which gas indicates efficiency?
CO2,
CO2. All of the gases are measured in percentages except what?
HC,
Hydrocarbons, how's it measured?
ppm.
Parts per million. You've been looking at that machine over, haven't you?
Yeah, that's it.
That's what you were there supposed to do. There you go. After the following exhaust emissions were measured, how was the engine operating? Hydrocarbons was 766 parts per million. CO2 was 8.2%. CO is 4.6%, and O2 is 0.1%. Let me tell you something. This sounds like an ASE question. So you better know a little something when you go in, particularly if you go into advanced engine performance. You're going to see exhaust tests on there.
What's an acceptable level of HC? The parts per
A pretty
million.
good question there. What do you think? Somebody else give me some
Say
input.
about 200.
If the newer the vehicle, the lower it's going to be.
It's gonna be too rich, so.
That's got to be too rich.
Yep.
Notice your CO is 4.6. CO needs to be really low. Hydrocarbons, on the really new cars, you'll see hydrocarbons down around almost none, like 70 parts per million or something, like less than 10% of this. And that's interesting to think to me when I had I would check all of our trainer cars, and at the time they were all running like they were supposed to. The older the car you check, the higher the hydrocarbons was. You know what I'm saying? The newer the car goes, the higher the CO2 goes, and the lower. Yeah, the emission system was more and more. And if it's basically, it's just one of the things that I noticed whenever we used to do exhaust gas analyzer.
GDIs would have really low, wouldn't they?
Yeah, that's the point. That's a small engine too. You got a smaller engine in a GDI car than you do in a but you get more power out of it. Technician A says carbon inside the engine can cause excessive NOx to form. Is that true?
Sure.
How so? Why would it do that?
It's too hot.
Yeah, whenever it's too hot, what's the breakover for making NOx? What's the temp? Remember? Cylinder combustion temperature. Okay, let's move on since we got the work order made. Technician B says excessive NOx should be caused by a cooling system fault causing the engine to operate too hot. That's true too, isn't it? That's 8. We got to make sure that we understand this. Could you guys intelligently discuss this if somebody just wanted you to sit down and listen to this, Moody? Your girlfriend sits across the table and says, I would really like for you to explain emission control to me. And you're sitting here saying, I mean, do you go be able to have an answer for her? What would you tell her?
Well, hydrocarbons are bad.
Yeah. Hydrocarbons are bad. That is a good statement.
Carbon dioxide is good.
Yeah. What's your 3 gases? Somebody tell me, what's your 3 gases, Webb? 3 gases you're controlling. What are they? What are you worried about? Carbon monoxide's a good one.
NOx.
Hydrocarbons and NOx. Okay, and carbon, you got oxygen and you also got water vapor coming out of there. Those aren't worried about, But I like to say, just make sure you can pull that up off your top of your head. Because you see, during final exam season, I may approach you and try to get you a chance to boost your grade a little bit by asking you something that you can answer off the top of your head. You'll have one chance. You know what I mean? In other words, in each course, I may come up and give you a little verbal exam. Yeah, I may ask you 4 questions. I may ask you 3 questions. I may ask you 1. I may ask you 10. You know what I
won't
mean?
have any blood over my door. Just
Yeah, yeah. All right, well, you're not gonna lose your firstborn anyway. All right, so, right here, we got, clogged VGR could cause what?
No.
NOx emissions, that's right. An ignition fault could cause what?
HC.
HD.
Hydrocarbons. And what else could it cause?
Knox.
Look at that. It could also cause CO if it was a mild ignition. Because you can have, what did I tell you about an exhaust, what about listening to the exhaust and it's sitting there going poo, 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 you know? I mean, somebody's got a spark plug gap too close or one's partially foul or something like that. Yeah, I mean, because my supervisor one time I was working down in Texas, he says, what do you think about this car of Bernice's? And I was listening to it and I said, sounds like somebody didn't gap a spark plug. We pulled them out and some of them were kind of partially burned up and all that. But anyway, put a couple of plugs in there and gapped them
Throttle
right.
body do that too?
Huh?
Throttle body.
Yeah, throttle body?
Throttle body.
Oh, any of them. I mean, if any of them that's got spark plugs, you know. If the plugs are gapped a little too close or they're partially fouled, it'll make a random misfire. Not missing every time, but
Hesitation, what you got?
yeah, and that's just idling. Now, if you're pulling and you're picking up something like that, that's going to be a, you know, spark wire, plug wire popping or a bad plug or something like that. But just remember that because that's part of the emission. That's part of the engine performance thing. And whenever we get through with our, we get ready to do our finals in some of these engine performance stuff, you're going to go out there and some of them you're going to plug your scan tool in and it's not going to talk. Some of them you're going to plug your scan tool in and it's not going to boot up. Some of them your scan tool is going to talk but it won't start and you may or may not know why. And so just be prepared for anything because the finals are going to be intense. And when you leave here, I want you to go tell your friends, do you know what he had us doing for finals? We felt all beat up when it was over with. You know what I'm saying? But basically it's, if you've done the worksheets, you'll be able to sail through the hands-on finals with no issues. You know what I mean? So anyway, which of the following is a measure of combustion efficiency, which is kind of redundant, but you know it's CO2. Which EPA bin number indicates a cleaner vehicle?
3.
That's actually A, yeah, okay. Vehicle,
You said CO2 or O2?
I said CO2.
Okay, because that one I got confused because I was like, okay, if it's CO2 then it's burning efficiency. But is it which one of
No, CO2 is what we were, you know, you're on. Anyway, some states, let's see, a vehicle is undergoing a shed test. What's being measured? A, how much hair comes off of its back. 2, no, that's actually air, 0 emissions, evaporative emissions, tailpipe gases, or lighting pollution. Lighting pollution? That's going to be evaporative emissions.
So she had like the,
Yeah, she made a nice wild guess over there. Some states have a testing program that some states have a testing program that uses IM 240. The number 240 refers to what?
A.
Seriously?
No.
C?
The 240 parts per million is dreadful for hydrocarbons. So, what is it? Who said what?
Is it Z?
Are you, what, you guys even have a clue?
No.
The
I'm not gonna lie on that one. I don't have a clue.
240 seconds. The length of the loaded test mode is 240 seconds. That's the loaded test mode. OBD2 equipped vehicles are required to turn on the malfunction indicator lamp if a system is detected an exhaust emission level that is how many times the FTP limit?
B.
That's going to be 1.5 times higher than. Oxides of nitrogen results from a combination of nitrogen and what? B. There you go. A vehicle being inspected under an OBD2 testing program is being inspected under an OBD2 testing program, and the mill is on. What will be the results of the inspection?
The vehicle will fail the test.
Immediately, yeah. Or if they plug in and they get a PO 1000, which means somebody's cleared the codes, you're going to fail it that way too. Got it? NOx readings at idle should be less than what? 100 parts per million. 100 parts per million. Well, that's not very much, is it?